Now it's my pleasure to invite Mr. Mustafa Aziz, Senior Solution Architect at General Electric, to deliver his presentation.
Assalamu alaikum. Thank you very much for inviting General Electric to this forum. And I would like to just apologize for Mr. Mahir Shebo on behalf of Mahir Shebo, who is the Chief Innovation Officer for Power Digital. He could not attend at the last moment because he is not well. So I took his place and changed the presentation a little bit, okay? So basically, I'm going to talk about how digital offerings are affecting utilities, and I will focus in on the power generation side. So we were blessed with computers right after World War II in 1946, and we all know that how the progress have been beyond exponential, okay? And there's an analogy saying that if something was used to weigh 25 tons, weighs 100 grams, should be weighing 100 grams now. 25 tons then should be weighing 100 grams now. But I don't agree with it a little bit, because hard assets are limited by physics, but information technology is not limited by physics. It just keeps on going on and on. And we all know that whatever you used to watch in Star Trek is reality now. 10, 15 years ago, what was there on science fiction TV programs or movies is really real now. And there is a lot of data, which is historic data. There's a lot of history and a lot of things to be learned in historic data, okay? And what is happening is that, especially on the industrial side, less than 2% of the data is intelligently analyzed, okay? And we lose a lot of insight. So what is in the recent last few years, there is increasing use of data science to unlock the hidden information in the historic data. And this is what we work with. And of course, what all this, you have seen it, especially on the healthcare sector, well-being sector with the smartwatches. It is making your life a little bit better and leading towards a more healthier lifestyle, etc. But when you talk about machines, this data can offer you huge potentials of flexibility and expanding the operating envelope of a machine. So we have got this grand vision of creating a system of systems, and I think whatever reports you see, from various agencies, it is predicting that everything getting interconnected. And the smart city concept started way back in 2010 timeframe, and I think and then there was a concept of smart grid. So I think it was a little bit slow and late in getting momentum, but I think now the momentum is really there because you have got the underlying technologies which are available to integrate everything. So what I want to talk about is the power industry is really changing. Okay, and we were just in the previous presentation, this is what we learned. So first of it is digitization, and digitization means improving performance through means of historical data analysis. And decentralization, because again, especially when there are a lot of rural areas, far off areas, there's a whole new way of looking at power distribution, power generation. And I'm from Pakistan, and I can see several initiatives which are on the ground to provide power to far off villages where there's not even possible to bring in a transmission line, or it's just too expensive to bring in a transmission line. And decarbonization is having a lot of effect. We were speaking yesterday, you have got a 500 megawatt PV. UAE has got a huge initiatives, and wind and PV is really catching on. I was reading in the US last year, all new capacity that was added to the grid was renewable based. So that's saying something, okay? But if you take the generation industry, there are things which are happening, okay? And first of all is that we are not short of, I think there are very few places in the world which are short of generation capacity. Again, I would say that prime example, Pakistan. 2 to 3 years ago, we were suffering 12 hours of blackout because there was no generation capacity. And now, if you see 30% or so, maybe it's not the right number, but significant number of major plants are shut down because there is no offtake. Okay, there is no demand. We've got so much installed capacity. And what that means is there is a aging assets are competing with brand new assets. Okay, so you've got a power plant which has got the latest generation turbine, which is 60% efficient, and you have got another person who has been operating a plant which is hardly 35% efficient, and he needs to do something to move up the merit order. Okay, and merit order really means something now. Okay, we did not used to think about that how efficient I am to be able to qualify to dispatch electricity, but that is really means something. Okay, and another thing what is happening is that we are all becoming very environmentally aware, and the NOx emissions, people are aware. Most of the places where I go to, especially where they are independent power producers, the regulation NOx, they are operating way below the regulatory NOx limits in most cases. Okay, so that is saying that okay, as an operator, I'm becoming more and more conscious of where I operate, even though I'm way. I mean, I've got a huge band of NOx which I can throw out in the atmosphere, but I'm so environmentally conscious that I strive to operate below the NOx environment. But there's another issue, is that people on power plants, it's my job to go and visit power plants all over the region and look at how they operate. And most of the places operate out of Excel spreadsheets. Okay, that's a fact. Okay, and so that there's this engineer who is sitting down trying to get data. He makes an Excel spreadsheet, try to make some graphs, and try to interpret what's going on. And that's predominant. And that means that data and people are not really connected. And then there is a generational turnover. New people are coming in who are very tech savvy. They're all used to, even the not so new or the young guys are also into this smartphones all the day. But when you walk into a plant, you are faced with the operator's log, which looks like that. Okay, and people, especially the young people who come in, absolutely lose interest in what the hell is going on. Okay, so there's a big gap to bridge to bring this into more intelligent and more what do you say, into a format which suits the mind of today. Okay. So when you go to a power plant and you ask for data to do some sort of assessment of where that plant is operating, the data comes in from many sources. It can come in from a SCADA system. There is historians, there is sensors feeding in data, there's a gas turbine control system. So there's a wide variety of data sources. And invariably, the data is messy. Okay? It has got issues with frequency. It has got issues with the unit of measures. One is meter per second, one is foot per minute, one is pounds per something, so on and so forth. So all that needs to be changed and aligned into a uniform format. And of course, so massive size, some sensor is reading at a minute interval, one sensor is reading at a microsecond interval, so on and so forth. And all this becomes that the data is very, very massive amounts. Even if you take a 3-month historic data for a combined cycle, 2x1 combined cycle, it's huge. So in GE, what we do is we offer solutions based on various levels. Okay, so what the first is the base layer, and we have talked about that is the platform. And for GE, we call that the Predix platform, which is no different than an iOS or Android, where it connects everything and you can develop your own small apps, etc., to have an insight into the data. Then, of course, you cannot disregard the cyber aspect of it, because we are cloud-preferred solutions, and the world is heading to cloud. And second part is the advanced controls. So I'll show you later on that we make a lot of interventions into the way we operate directly into the control system. And when you do that, first of all, you need to have huge protection as far as cyber is concerned. So we end up operating within the plant data highway, so you are not exposed to the to the internet of the company. You are confined within the plant data highway. You are sitting next to the machine. And that is what we call advanced controls. And because the computation required is into seconds or milliseconds kind of thing to make that judgment of where you want to operate. And that is not possible to take that much amount of data into the cloud and compute and throw a result back. So that's what the advanced control side or edge computing. Then we talk about asset performance management, which just talks about reliability. We talk about operations optimization, which is primarily either a megawatt increase or a fuel saving. And we talk about how you dispatch. Okay? And in this market, operations optimization and asset performance side plus this makes more sense because you're not really into an energy trading scenario at this point in time. So the core technology, what we have is, again, data from various shapes and forms and sources, pushing into what we call a digital twin. Now, digital twin is a model. It could be at a component level or an actuator for an undercarriage for an aircraft. Or it could be an asset level, which is a gas turbine or a transformer. Or it could be a system level, which is one block of a power plant or a complete power plant. So we work in all three aspects. And most of the digital twins either are math-based, which I'll show you an example, or could be a physics-based. Okay? And when we talk about physics-based, we talk about thermodynamics. Okay? And because the power plant at the end of the day is all about thermodynamics. It's fuel burnt versus megawatt produced. Okay? So that is, we are striving to optimize that. And increasingly, there is neural nets are coming in, and they are calling on physics models as well as math model to give out something. But that's, I think it's a little bit in infancy stage at this point in time. And all it does is gives you certain improved visibility, improved reliability, better performance. So talking about asset performance management, this is a typical operating cycle of a power plant. So you start up, you go to the base load, and then the grid may ask you to come down to a little bit from the base load. And when that happens, of course, your optimized fuel burn is over here. And when you go down to a part load scenario, your fuel burn becomes less efficient. And then you may be asked to shut down or go to extreme minimum load, and then again recover as the grid demand increases. So what we say, so we have designed our solutions which can make a difference on each of these operating regimes. And so when you talk about solutions, it's basically 4 or 5 levels. Okay? So if you start with the top, which is primarily a cloud-based level, that is just looking at your key performance indices. What is my heat rate on this gas turbine? What is the heat rate? Heat rate is fuel burnt over megawatt produced. Okay. What is my heat rate on this particular gas turbine at the power plant level? How much fuel I'm burning, et cetera, et cetera. And these KPIs are quite deep because it's just not like a simple equation, one divided by the rest. It has got a lot of information which it requires historic as well as the real-time thermodynamic to come out with the KPIs what you're looking at. So this is basically a KPI level. Then it's an advisor level that when should I do a certain intervention into the plant? Okay, what is the most optimal time? Okay, and I'll show you an example of that. That's what we call an advisor. Optimizer is what I told you about the edge controls, that you are running and giving you the most optimum set points to operate the plant on an hourly basis. Okay, so and that is being done primarily at the plant or the asset level, and it involves a lot of real-time monitoring and computations. Then you have got certain control-based automations, and finally we have got thermodynamic simulations to come up. Let's say if you are doing an equipment change-out, you want to add another FD fan, or you want to add a cell of cooling tower, what will happen? Okay, so you can run thermodynamic simulation based on your exact design of the plant, and that's what we call the what-if tools. So this is an example of a water wash advisor. Okay, so what you do with the plants, with the gas turbine degrade as they operate, And once they degrade, you have to shut down the gas turbine and wash the various sections out. And usually people do it at a fixed, you do one today, and then okay, after this X thousand hours of operations, I'll do it the next one. So what we do is we have got a thermodynamic model running, and that predicts, that takes the cost of the wash in cost of production, cost of lost production, cost of the chemicals involved into account, as well as the day-to-day thermodynamic performance of the plant, and it can give you an optimum that this is where I should be washing to get the most benefit out of it. This is real-time thermodynamics in action. Second part is what we call about the edge controlling. So we have got, again, a thermodynamic model. We do the desired computations. You push that result set into your DCS or the control system, and then you make an adjustment and for the next hour of operations. And this is how it, if I go back, this is how it looks like. So we have got this water injection, and what we do is we can come back in, do the best case scenario based on the demand, the weather, and the degradation of the plant being calculated in real time, and make an adjustment into the control system that this is what the best operating point is. And we work with about 6 or 7 types of various interventions into the control system. So that said, that our operations optimization solutions fall into these 4 categories: efficiency, flexibility, capacity, and emission control. And we have got solutions for each of these. And again, if you see a typical power plant, every bit counts, and every bit can make a digital impact into the thing. On asset performance management, there's a new concept called unified asset performance management, unified asset performance management. And that talks into reliability strategy and mechanical integrity aspects. And I just want to touch on the predictive analytics part. So the bottom line is that machines don't fail in a linear fashion. And there's an outage, there's a sudden deterioration, and the machine goes down. So idea is to pick that deviation as early as possible. So when a machine operates, there's a sensor which is throwing in data. And if there is an abnormal spike, which is well below a trip limit, which is controlling or protecting the machine, you will never know about it. So what we do is we learn the normal behavior of the machine. And and we come up with, say, that each machine develops its own history, that this is where I should be operating. Okay? And if there is a deviation, and if there is persistency, we can detect that and throw an alert out that something is not right. And when we throw the alert out, it's not done in a single dimensional, it is done in a multi-dimensional. So you are reading not only the main sensor, but you're reading the contributing sensors around it. And then you are mapping those deviations into either the machine history, the fleet history, and then you can predict that, okay, at this point in time, I see a deviation which is persistent, and that may lead to a failure, let's say a bearing or a seal, air seal leakage down the road. And since this is picked up much before the control limit the threshold is reached, so you have got time to plan it. And this is what we have got. This is the math model of a gas turbine. And so this is how it is done. Okay, so you have got the historical data, real-time data, you compare the two, make an estimate, and diagnose. So the industry is changing. Finally, there's a marriage of physical and digital in the power generation side. And we can have got initiatives across the complete value chains looking at digital technologies affecting the physical assets. Thank you very much.
Thank you, first of all, for the great presentation. So thank you for the great presentation. I will get for the first questions from the live stream for Ms. Nita Kojal. What will happen in terms of job losses and skills as IoT makes devices and robots more intelligent? By Saeed Luhabi.
That's a really good question. The topic of job losses comes up a lot. But I think it's not something that we should feel insecure about, because where there are going to be changes to jobs, there are also going to be new ones created. Because you would have seen from some of the presentations today that if there are some new services that are going to be offered to our customers, then naturally there are going to be new jobs created for those as well. They will just be different ones.
Mr. Mustafa, I have a question for myself actually. You talk about the generation part of the business. I would like to ask, based on your experience in GE, that which stream of the utility from generation, transmission, distribution, and supply will be more impacted in adapting or not adapting new technologies?
Okay, I think we have been talking about the complete energy value chain from generation all the way down to consumption. And if you go back from 2007 to 9 time frame, there was a lot of effort which was put into the demand side management, the off-taker part, okay? So this whole digital revolution, in my opinion, started from the demand side management, okay? But I think what has happened is that demand side management, the scope is very vast. You know, here the cities are smaller, but elsewhere in the world, the cities have got 20 million people on it. So the impact is of course, so if you're talking about the biggest bang for the buck, okay, we cannot disregard distribution because this whole revolution started from the distribution side. But in my personal opinion, the power generation side really makes a difference, because if you can save 1% less fuel, or if you can produce that X number, 20, 30 megawatt more from an existing gas turbine, that's huge impact, depend on the type of operating scenario you have, okay? So yeah, you cannot disregard the whole value chain, but since I am from a generation experience, that is the biggest bang for the dollar what you spend, okay, in my opinion.
Another question from the live stream as well is to Ms. Nito Kojal. Will IoT actually work over the internet, or will it have its own dedicated wide area network?
That's also a very good question. Now, you do have some services that can run over the public internet. It really depends on the security controls that are being implemented. Services such as utilities, because they are so key, you wouldn't expect the services to be running over public internet. So you would expect some implementation of private networks for them in general. Now, what we are seeing is there is a split of different types of services that are being created, where you have optimum services that will be secure, private, and something that you will have a good measurement against. And where providers are testing and trying new types of technologies, maybe they don't mind trying them over the public internet so much, so they will be separated. So these are common trends that we're starting to see come across the board, which are allowing utility providers who are quite risk averse to adopt new types of technology.
One general question also on the live stream was, what effect will the Internet of Things, IoT, have in our daily lives? I would direct this to Mr. Mustafa.
Well, I think the effect is already there, because when you search Google or when you go on YouTube and when the type of ads you get, but that's on a personal life aspect. And I think especially on the when you talk about the battery limits of a power plant or a petrochemical complex, that effects have just started. Okay, so wherever we have got these things implemented, the lives of the people on the plant and the management has changed tremendously, because they have got totally new insight on how they operate and where they operate. Okay.
One more question on the panel is, Ms. Nito said that utilities are normally slow in adaptation of IoT or new technologies. My question will be is what can utility do to make a faster adaptation, and what will be effect if not adopting as fast as required?
I would probably start off by thinking about what are the key problem areas and what could be the catalyst to drive those changes. The catalysts are generally regulation. Utilities is underpinned by strong regulation in every market. So thinking about what type of regulations could really be changed to stimulate some of that technology driver. It could be around maybe generating more digital cities, these smart cities. It could be around reducing carbon emissions, so what could actually reduce that. It could also be things that are ultimately going to help the businesses reduce their costs. So those types of changes, you need them to be fed into either the regulation side, or you need some sort of stimulus on the customer side that's really going to be driving those changes. We are also seeing that as the competitors are really moving forward, providing services that are really tailored to your customers is also going to carry on being a key pressure point. So keeping with your competitors is going to be another thing that's going to help make those changes happen.
So I'm just checking if there is no other questions. Yeah, Zahila.
First of all, thank you very much for your great presentations. My question is to Ms. Nito. One of the things you mentioned in your presentation is the risk of change in regulations. My question is, how do you deal, or rather plan for such changes? Thank you very much.
Regulation changes are no easy thing, and they take a very, very long time. The planning actually starts more than 5 years in advance, with hefty contracts that need to be negotiated with, and how the regulators are actually opening up the market to allow for adaptable tariffs to be implemented, or different types of changes for consumers so they can switch their utility provider much more easily. Those are the types of regulation changes that need to be implemented, and they take a very, very long time. So there's no easy answer to that, but they take a long time to negotiate. And we're seeing some of that actually happen in some of the European countries that my team look after at this point in time. And the process started many, many years ago.
We'll take one last question from Engineer Saleh.
Okay, thank you very much for the informative presentation. In fact, my question is to Mr. Mustafa from GE. You spoke about decentralization, and if we look to the distributed generation rather than central generation, how would the Internet of Things and artificial intelligence is going to help both the customers optimizing their consumption as well as the utilities on the other side?
Okay, look, I think I'm not an expert on distributed distribution, but what I can guess is that the traditional generation is not going to go away, because you need to have a certain base load in order to keep the grid stable and to operate, okay? But there are interventions coming in which distributed will make an impact on the health of the main grid, okay? Health and stability of the base load grid. And I think that's where the visualization and the impact of information technology and IoT will make a huge difference to keep that base load stable, because distributed is pockets, all right? And base load is base load. You got to have that, all right? So that's where I think it'll make the grid more stable, yet not deprive people who need the distributed generation also. So that's my take.
That is a very good question, especially Engineer Yaqub is just beside you. So exactly. So one more question, I think in the top of the hall.
Qais Al-Amri from ITA. Guess I have a question for Ms. Nito, that I like your speech about the smart meters. But what kind of challenge that we might face when you plan to build it here in Oman? And for Mustafa, I like your word when you say that now I believe that the physical and digital now married. But I think that we are thinking about the security area. I remember when WannaCry coming in the UK, especially in one of the hospital, was facing that the attacker was trying to fight that they will cut the electricity from the hospital if not get a bill. So I think that we need to invest more in the security area, because there is many risks when you're planning to get married, you know? Okay, thank you.
So maybe the first part of the question to Ms. Nito.
Okay. If I maybe repeat the question back to you, if that's okay. I guess what I understood the question to be was, smart metering is important, but what are the kind of key challenges that we are going to be facing specifically in Oman? I would probably say that where you already have existing infrastructure, there are already existing buildings, there, providing smart metering and enabling that network is going to be a lot more easier. Where you have new construction, where you have new generation and expansion of your current city to accommodate maybe a growth in population, or Tanwar, for example, is another use case. In areas like this, you will be limited by your current infrastructure. So knowing how and when that takes place will then enable all of the different smart metering that you also then need to roll out. But with the smart cities, which is something I enabled in Spain, what we looked at there was, how do we forget about the big cities, but we look at the smaller ones? Because the smaller ones maybe don't have some of that legacy infrastructure that really limits some of these small cities. And actually going in with new technology that could be cellular based actually works out a lot more cost effective. So there's a two kind of things that you need to look at, and they do balance each other. So it depends on the location, depends on the underlying infrastructure, and also cost elements as well.
The second part of the question.
So as far as
Mustafa.
cyber security is concerned, that is a very valid observation. And that's why in the core offering, what you see is that it's a cornerstone of any implementation, okay? And the second part which I want to say, and that's why we talk about data diodes and things like that. That's one of the first things which customer ask you, okay, prove me that this is cyber secured. Second part is that when you saw the edge computing concept, which is where you are making actually interventions back into the control system, that is absolutely isolated from any sort of an internet, okay? That's why I talked about the plant data highway, which is within the operational environment of the plant. So it does not go out. So what goes out is literally a data which is 2 to 5 minute interval, such as the reliability data or the KPI related data, okay? But the core, wherever there's intervention, is still within the confines of the firewall. It does not go out.
So by that, we'd like to thanks again our speakers and the guests, whoever give us these great questions, and the audience. Thank you very much.
Thank you.
Thank you.